In the last section, we showed why we needed a product rule. All right, recall that if we wanted to take the derivative of the product of two functions, f times g, this was not generally the derivative of the f times the derivative of g. To show that, we use the example f of x equals g of x equals x. And if that were the case, then the derivative of f times g would be the derivative of x squared, which would be 2x. And the derivative of f would be the derivative of x, as would the derivative of g. So the derivative of x is equal to 1, so we'd have 2x would be equal to 1. And of course that's not true. So the derivative of the product of two functions is not the derivative of the function. So what we have to do is we have to decide what is correct. We can decide this using the definition of the derivative. All right, so that the derivative of f times g is the limit as h goes to 0 of f of x plus h times g of x plus h. Remember this function, f times g, where each instance of x has been replaced by x plus h, minus f of x times g of x, this function itself, all divided by h. The question is, what does this numerator look like? All right, the numerator is kind of a complicated expression. So here's the thing. Here's what we have. Suppose that we have the graphs of f and g on separate axes. Notice the axes have been rotated. Here's the x-axis and the f of x-axis, so this is in the standard position, but here I've rotated them 90 degrees clockwise, so this is g, and then this is x. And then if I look at this, of course, as the value of x changes, I'll get basically the value of f of x changing, and I have here an image, a rectangle, and this part down here is at 0 at the x-axis. This is at f of x, so this dimension is f of x, this is f of x, and this is f of x plus h, so this is f of x plus h minus f of x. The similar thing over here, this is at 0 on the g-axis, and this is at g of x, so this is g of x. And then this is at g of x plus h, so this is g of x plus h minus g of x. Okay. Now what happens is, if we look at this yellow rectangle, this yellow part right here, all right, this part is f of x times g of x. So when I subtract that off, I'm just removing that yellow part, and I just have these three parts left. Let's take a look at that. All right, so with these three parts left, remember the area of this red rectangle would be f of x plus h minus f of x times g of x. All right, the area of this green rectangle would be f of x plus h minus f of x times g of x plus h minus g of x. And this one would be f of x times g of x plus h minus g of x. So what we have is that this numerator is basically this entire rectangle, which, by the way, which would be the area of it would be f of x plus h times g of x plus h. And when I subtract off this f of x times g of x, I lose that yellow rectangle here. So I just have these three left. And here are those expressions. I've color-coded them. This is the area of the red rectangle right here, the area of the green one, and the area of the blue one. Okay, so now let's do some algebra on this. Okay, if we look at this, I could separate this one fraction with a denominator of h into three fractions that I add up each with a denominator of h. So I have f of x plus h minus f of x times g of x all over h, and then the area of the green rectangle all over h, the area of the blue rectangle all over h. All right, further, I could take this quotient, or this fraction here, and write it as a product of two fractions, f of x plus h minus f of x all over h, times g of x over 1. I put that in because sometimes students have a little difficulty with the fractions. I'll do the same thing here. I have this part over h times this part over 1. Again, if you multiply those together, remember how you multiply fractions, multiply the numerators, multiply the denominators, we get back to what we started with. Excuse me. And then finally, I have this, this last one, we'd have f of x divided by 1 times this g of x plus h minus g of x all over h. Now I want to do a little bit of work on this, all right, so that I can get ready to take the limit. And here's what I'm going to do. I'm going to take this last fraction and multiply and divide by h, so that this expression will become f of x plus h minus f of x over h times g of x plus h minus g of x over h times h. And now I'll start to take the limits. I can take the limits term by term. And remember then the limit of the product is the product of the limits. So I'll end up with this limit of f of x plus h minus f of x over h times the limit of g of x. All right? Then time plus the limit of f of x, the same limit, f of x plus h minus f of x all over h times the limit of g of x plus h minus g of x all over h times the limit of h. Again, all of these are as h approaches 0. And then times the limit of f of x as h approaches 0, times the limit of g of x plus h minus g of x all over h. Now, as I take these limits, all right, this one, provided that the function is differentiable, f is differentiable, this limit turns out to be the derivative of f. This is just the definition of the derivative. The limit as h approaches 0 of f of x plus h minus f of x over h. This one, since g of x does not depend at all on h, as h goes to 0, nothing changes here. All right, so this is just g of x. All right, by the same token, this one is the derivative of f of x. This is this definition of the derivative where instead of f of x, we have g of x. So if g of x is differentiable, we have the derivative of g of x. And of course, this limit as h approaches 0 of h is just 0. Okay. Plus, in the last term, this is just f of x, because it does not depend at all on x. And this is just the derivative of g of x. So notice the center terms drops out because we're multiplying by 0. And we get the derivative... excuse me, we get the derivative of f of x times g of x plus f of x times the derivative of g of x. This is what we call the product rule. Now, this is not exactly the way it's written in your text, but let me point out what this is like. All right, we want to take the derivative All right, we want to take the derivative of f times g. They're the product of two functions. Excuse me, the product of two functions. All right, so since there are two functions, I'll make two copies of the product. All right, and in the first copy, I'll take the derivative of the first function. In the second copy, the derivative of the second function, and then add them up. And this is exactly what the product rule says.